The world-famous blast on August 23, which was believed to have been caused due to sparks originating from welding, caused a heavy buildup of hydrocarbons in a pipeline. This led to the blast and collapse of the cooling tower. It was later realized that the cooling tower was not considered hazardous, and therefore welding operation was being performed. The result, a fatal accident. Lack of knowledge in hazardous area classification can be very serious and fatal, causing irrevocable damage to life and property. Where is HAC applicable? Let us consider a few industries that can be brought under hazardous area classification. In short, all industries which handle flammable materials need hazardous area classification and proper selection of electrical equipment. For the purpose of hazardous area classification, we consider any flammable material whose flash point is less than 65 degrees centigrade. However, if the material is being handled above its flash point, it is also considered for hazardous area classification and must be treated accordingly. Click on the images to see more. Petrol bunks and service stations involve a lot of flammable material, like petrol and diesel storage and dispensing. Aircraft hangars too handle flammable material like aviation fuel, which is highly flammable. Printing industry has solvents for inks, such as hexane, methyl, ethyl, ketone, and acetone, which are flammable and pose a significant risk if not handled properly. Dry cleaning industry handles a significant amount of flammable solvents for the purpose of dissolving the dirt or sticky matter. These solvents need particular care so that they don't find an ignition source. Oil refining and petrochemical industry store and deal with highly flammable materials, and the hazards are obvious as it can get. Drugs and medicine manufacturing industries handle solvents for drug manufacturing and cleaning the containers for manufacturing. Solvents like methanol, isopropyl alcohol, acetone, etc. are used in this industry. Paints manufacturing industry also produce the final product using solvents like isopropyl alcohol, methyl isobutyl ketone, etc. They also handle a variety of flammable resins, which are stored above their flash point. Vegetable oil industry solvent extraction plants produce oils, which are flammable and are stored until dispatch. The extraction and storage areas need particular attention. Fermentation industry has ethanol as a common example. Ethanol is a flammable fluid, and any electrical equipment around the process and storage areas need particular attention. Synthetic resin and plastic manufacturing handle a variety of flammable resins and glycol ethers. What are zones? A plant which handles flammable materials is divided into zones. Hazardous areas are classified into zones based upon the frequency of the appearance and the duration of an explosive gas atmosphere. To help select the equipment, the knowledge of the zone is essential. Let us see the different types of zones in hazardous areas. There are 3 zones for hazardous area classification. The 3 zones as per IS 5572 and IEC 60079 are Zone 0, Zone 1 and Zone 2. In USA, as per NFPA standards, there are only two divisions, for example Division 1 and Division 2. We will be focusing mainly on IS or IEC method for the remainder of the discussion. We will shortly look into the nature of each zone. Zone 0 is an area in which an explosive gas atmosphere is present continuously, or for long periods or frequently. For example, inside of a tank or container containing flammable liquid that has continuous presence of flammable vapor. This zone is synonymous to Division 1 as per NFPA standards. Zone 1 is an area in which an explosive gas atmosphere is likely to occur in normal operation occasionally. For example, the space around the vent of a tank holding flammable liquid may have a flammable vapor around it occasionally. As per NFPA standards, both the zones, for example, Zone 0 and Zone 1, are represented by Division 1 only. Zone 2, area in which an explosive gas atmosphere is not likely to occur in normal operation, but if it does occur, will persist for a short period only. For example, the space around the vent of a tank holding flammable liquid may have a flammable vapor around it, exceeding the occasional limits only, for short periods of time. As per NFPA standards, Zone 2 is represented by Division 2 only. So, what we just learned is that, inside the tank is Zone 0, because there is flammable atmosphere always present. Around the vent is Zone 1, because the flammable vapor is present every time the level inside it changes. And very rarely, the flammable vapor is encountered in the Zone 2 area. Case study. In a recent incident involving oil storage tank in a facility, there was a catastrophic blast and explosion leading to huge damages. At this facility, the oil containers were designed to have floating roof tank tops, within which flammable solvents were stored. These tanks are sealed at the rim using a mechanical shoe, as shown in the image, to check the egress of volatile solvent vapors. They are designed and built such that these rim seals do not prevent the volatile vapor from escaping. The floating roof tank moves up and down in accordance with the level of liquid contained in them. During a heavy thunderstorm, blast sounds were initially heard from two oil storage tanks, which then immediately caught fire, leading to massive losses. What do you think went wrong? In this situation, if the free vapors escape and find an ignition source, an explosion can occur. The ignition source can be as small as a spark from dropping, that is free falling of a non-insulated tool, or as large as lightning. In the case of this facility, the imperfections in the mechanical rim seal fire component lead to a poor contact of shunt between the rooftop and shell, causing the vapors to escape. The vapors, once they leak out, they form an explosive atmosphere around the leak, and on finding an ignition source from the lightning, cause the fire and explosion. What could have been done to avoid the incident? The recommendations in this case are: to earth the floating roof tanks every 30 meters with the earthing resistance of 0.03 ohm, to install submerged shunts, and to install a foam-based extinguishing system for Class A flammable liquid storage tanks. You could read further about such incidents from the following references.